Okay, here we've got a vector question starting with the equation of two lines, and the first thing we've got to do is show that they're perpendicular. So this is essentially the angle between two lines, and for that only one thing matters about each line. You can read off these two vectors. One will be the position vector of a point on the line, and the other is the direction vector. And of course, for the angle between two lines, you need to pick out the direction vectors. So you'll have two column vectors, which are the direction vectors. And to show they're perpendicular, you need to form the dot product, the scalar product. Show clearly how you're working it out, but of course you need the answer to be a particular value in order to show they're perpendicular. So you get that answer and claim they're perpendicular. Then in part B, we've got to show they intersect and find the coordinates of the point of intersection. Well, to make them intersect, we need to compare x's and y's and z's. So the x's, to start you off, will be, the x coordinate from this equation will be 8 plus 3 lambda, and that's got to agree with the x from the second equation, and so on for y's and z's. Now leave the z's on one side to begin with. Just the x coordinates and y coordinates will give you simultaneous equations, which will give you a value of lambda and a value of mu, which need to be those values in order to make x and y agree. You can then check out the value of z given by the lambda and by the value of mu, and they need to be the same value to prove the lines intersect, so that when x and y agree, z also agrees. And once you've done that, that's shown they intersect. To find the coordinates of the point where they do intersect, you need to calculate the x value from this equation and from this equation and show they find out what that is, and the y value from this equation and this equation. In fact, either one of the two equations will do the job, but a double check is that you do get the right x's and y's from both equations by using the right values of lambda and mu. Then on to part C. This is where you need a diagram. Sometimes the diagram will help, sometimes it won't, but you won't know whether it will help unless you've had a go. So we've got lines L1 and L2, and we've got to remember we've shown they're perpendicular. And we've got the point A, which lies on L2, there, this is L2. P, of course, is the point of intersection, which is mentioned here, and AP equals BP, and we've got to find the distance AB. Now, if I can work out what AP is, then, which I can, I mean, I know the coordinates of A, and I've worked out the coordinates of P, so the distance AP is just a known length. And if BP is the same, then I've got two sides I know, and if I know that's a right angle from the first part, I can use simple Pythagoras to work out the distance AB, and then I'm done.